Okay, we're looking at example A.8. And I did it out for you, but let's go through the steps. We have 4a to the 3m plus 2 minus 16a to the 3m. And they ask us to factor. So what I'm going to look here is, remember, when we have a base and these exponents are added, you can rewrite it as 4a to the 3m, a times a squared, minus 16a to the 3m. By doing this, we can see we have a to the 3m, and we have a common factor of 4. So I pulled those out. And what we get left with is a squared minus 4. Now this is the difference between two squares. So you can then factor that again, or you could recognize that it's the difference between two squares. And we have the factor 4a to the 3m times a plus 2 times a minus 2. Now, to factor out these two here, we're going to do them separately, but let's do a first. I look up here and I've got a bunch of cubes, and I don't have anything common. So what I want to recall is, how do we factor the sum or difference of two cubes? So remember, you take the first one and you cube it, and if it's plus a sum times the second one cubed, then what you would do is you would say f plus s, which is the first one plus the second one, the first one squared, minus the first one times the second one, plus the second one squared. If this was a minus, then this becomes a minus, and this one here becomes a plus. So that's the formula we're going to use. So now let's look at part A. Now we look at 8a cubed, and you think, okay, is that a perfect cube? Well, yeah, it is. It's 2a cubed. And when I look at b cubed c to the 6th, I'm going to write it as b c squared cubed. When I multiply these out, you multiply the exponents and you would get b cubed c to the 6th. So if that's the case, then I can write the first one minus the second one. Take the first one and square it. Now you have to square the 2, and you also have to square the a. Then you would take these two, multiply them together, and it's the opposite sign, and then you take this one and square it. So b squared c to the 4th. Now let's look at part B. We have an m cubed, an x cubed, and a y to the 6th. So let's rewrite it so we can see if it is a sum or difference of two cubes. So I take m and I cube it. That would work. X and I cube it, I get x cubed. Y squared, when I cube it, I get y to the 6th. So this is my first one, this is my second one. I take the first one plus the second one. And then I take the first one, right here, and I square it. And then I multiply these two together, and it's the opposite sign. And then I square the second one. And that's how you would get those answers. Alright, let's look at example A10. It's telling us to take 14 factorial divided by 6 factorial divided by 11 factorial. And if you recall, a factorial is just a shortcut way to write 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now I'm going to write 6 factorial. 11 factorial is going to be 11 down to 1. So these two will cancel. So now what I've got left is 14 times 13 times 12 divided by 6 factorial. So then I'm going to write 14, 13, 12, 6, 5, 4, 3, 2, and 1. 6 times 2 is 12, so these two will cancel out here. So I'll write it like this. These two cancel out this 12. And now I've got an even number, 14 and 4. 2 goes into both of them. 2 goes into 4 twice. 2 goes into 14 7 times. So now what I have is 7 times 13 divided by 5 times 2 times 3. And that will give me 91 divided by 30. Now the second thing we're going to do has to do with summation notation. Some of you are not used to this, and so we're going to talk about it a little bit. It is review in some algebra classes or pre-calc classes, they go through this. So I am just going to write down what we have in example B. This is the Greek symbol sigma, and it goes from j equals 0 to j equals 3. And we're talking about integers. And this summation says whatever I have here, I'm going to add all these individual things from 0 to 3. So it's 2 to the j divided by j plus 1. So I start off with 0. And I write 2 to the 0 over 0 plus 1. 2 to the 1 over 1 plus 1. 2 squared over 2 plus 1. 2 cubed over 3 plus 1. And now what I have is 2 to the 0 is 1 over 1. 2 over 2 is 1. 2 squared is 4 over 3. And 8 over 4. So now I have 1 plus 1 is 2, plus 2 is 4, and I get 4 plus 4 thirds, which is 16 thirds. Now part C says, let's take this summation notation. There are no j's here. All it's telling us is that for each integer between 1 and 4, we're going to add up 3. So, if I take the first integer, it equals 3. If I take the second integer, it equals 3. If I take the third integer, it equals 3. If I take the fourth integer, it still equals 3. And so now we have 3 plus 3 plus 3 is 12. Now we're done with lesson review A.